In this video, I want to go through the topics that are going to be covered on your first exam this semester. So let's just jump into it. First, it's no proctoring software is going to be used on this exam. You're going to be working on your own. Should you decide to work with somebody else or get help and I find out about it, and I always find out about it, I will be using the proctoring software on future exams. So work by yourself. Open Book and Notes. You can use all the material you have. You can Google stuff. You just got to work by yourself. And hopefully you won't have to Google things, but working by yourself, Open Book, Open Notes. Once the exam begins, you have a set period of time. I believe it's 90 minutes this semester for this exam. Just got to carve out some time to take the exam. The topics, we started the semester talking about statistics. We collected some data, we organized, summarized, categorized, we interpreted, analyzed numerical and categorical information. Everything and anything to do with data falls under that definition of statistics. We talked about two different branches or applications. If we're describing the data that we have in our sample, that's called descriptive statistics. If we're using our sample to make statements about populations, which is where we head to in the second and third subsequent parts of the semester, that's called inferential. So the decision whether it's descriptive or inferential really depends upon which group of data we're making statements about. Samples or population. Samples, it's descriptive. Inferential, you're talking about populations. The basic terms, population, sample, experimental unit. All of the things that we're working with, all students, all cars, all apartments, all homes would be the population. The sample is the ones we have. In your project this semester, I believe you collected 75 automobiles, apartments, or homes. Maybe you have a sample of 300 students. The data that you actually have in your data set, that's your sample. And then a single one of those, a single student, a single automobile, home, apartment, that's the experimental unit. So all sum one, you should be able to differentiate. The things that we're taking notice of, the information we're collecting, those are called variables. The age of the student, the GPA of the student, the size of the house, the price of the automobile. Those are variables. Some of them are numerical and they're quantitative. Some of those are categorical and they're qualitative, like the model of vehicle or the location of the home or the apartment. Those are qualitative pieces of information. The age of a student is quantitative. Their hair color, their hair color is qualitative. Reliability is just a term that we use for when we make our inferences later in the semester. We're going to have a measure of the reliability. Sometimes it's called a confidence level. Sometimes it's called a measure of error. You may have heard those terms from other schools or other places, other statistics classes. We're going to look at those later in the semester. I've talked about three different methods of collecting data. There's a published source, there's a designed experiment, and then there's observational data, observational studies. You should be able to differentiate between them. I have to write a good question so you can, but there are three different methods of collecting data that you should be aware of. Random sampling, that's a sampling technique that we talked about in class where every experimental unit has an equal chance of being selected. Every combination of n experimental units has an equal chance of being selected. That's I won't say the best way, it's maybe the easiest way to get a representative sample of the population, and we did talk about that a little bit. I didn't require that on your projects this semester, but you should be aware of what a random sample is. I'm going to be providing some charts to you on the exam and asking some basic questions. The charts that we've seen this semester are pie chart, histogram, stem and leaf display. Those are the ones we saw early in Chapter 2, and then after I talked about some numerical descriptions of data and talked about outliers, we also saw box plots. So you should be able to answer basic questions, and I'll be using the software that we're using in class this semester to create those charts, those displays, and asking some questions. There's three measures of center. We move to numbers now. Mean, median, and mode. You should know how to interpret each. You should know when the median would be the preferred measure, skewed data. You should know when the median or the mean would be the preferred measure. That's symmetric data. For the measures of spread, really the only measure of spread you need to worry yourself with is the standard deviation. That's the one that we work with. There's also a variance, which is kind of the math involved with the standard deviation. Standard deviation is the square root of the variance, and then there's a range, which we won't use much at all. But you need to be able to interpret a standard deviation, and the way that you interpret it is based upon three rules that we looked at. Chebyshev, empirical, and modified empirical. Chebyshev always works, doesn't always work well. Empirical works great when you're working with symmetric data, and modified empirical I gave you so that when you're working with skewed data, which many of you are on your projects, you can still interpret the standard deviation as if you were working with the empirical rule. For the empirical and modified empirical, we expect most things to fall within 2 standard deviations of the mean. If we're forced to use Chebyshev, we have to bump that out to 3 standard deviations. You should be able to do additional work with Chebyshev and empirical. I'm going to give you some problems where I asked you to go through those rules. So make sure as you're going through your exam, you have the Chebyshev numbers, you have the empirical rule numbers. Really, the modified empirical is just to help you interpret a standard deviation when you're working with skewed data. Let's back up here a little bit and talk about measures of relative standing. There's 2 of those: percentiles, which tell us the percentage below a specific point. So the 80th percentile is 80% below, and of course 20% above. The 15th percentile is 15% below and 85% above. The other one we looked at was z-score, and that's a formula that you should have handy because you're going to have to calculate a z-score for me for some observations. And we use z-scores to detect outliers. Outliers are those observations that are out there, and how we define or detect outliers is based upon which of the rules we're looking at. Are we looking at Chebyshev, in which case the outliers are the ones that have z-scores outside plus and minus 3? Or are we using the empirical and the modified, in which case we bump that into plus or minus 2? So z-scores are one technique, one of our methods of detecting outliers. And then, of course, I've already mentioned the box plot is another method. And that's just a graphical display where we look for different symbols. And different software packages use different plotting symbols. You know what we're looking at this semester. Just tell me how many types or how many outliers you can detect in your plot. As far as probability goes, just a probability table. I'm going to give you a little 2-variable table. We looked at, I think, automobiles in the lecture. Took a look at, if I remember correctly, the color of the automobile and what type of transmission it had. And I asked you some OR questions, some AND questions, some conditional probability questions, basic probability questions. You should be prepared for several probability questions on the exam. They're not really difficult, but if you try to work real fast, they're easy to mess up. Then we switched and moved to random variables. And a random variable is just a variable that describes or assigns a number, probably a better way of saying it, assigns a number to the outcomes of the experiment. The number of students with a tattoo. The number of houses that have operable smoke detectors, if I take a sample of, say, 20. There's 2 different types of random variables. The ones that we've looked at early in the random variable chapter have jumps. And what I mean by that, it's the number of students with a tattoo. It's either 0 or 1 or 2 or 3. You can't have 1.5 students with a tattoo. You can't have 1.4 students with a tattoo. So the landing spots for the values of x are kind of distinct. They jump from one value to the next. Whereas a continuous random variable, well, it can be all over the place. My drive time to USF, it can be anywhere between like 20 minutes and an hour. And anywhere in there, and it's not like it jumps from 25 minutes to 30 minutes. It's continuous in nature. So we start, and this exam only covers discrete random variables. The probability distribution part is where we assign probabilities. What's the probability we see 0 students with a tattoo? How about the probability of 1, of 2, of 3? And we know there's 2 rules with probability distributions. Probabilities have to be between 0 and 1, and when you sum them up, they have to sum to 1. I've talked about discrete and continuous. This little expected value formula here, E of x, or the average or the expected value of x is equal to the sum of, forget about the 1 in the end, don't worry about that, but we take the values of x and multiply by the probabilities. How many of the students do I expect to have a tattoo? I went through that example with in class. And it's a simple little formula. You should be able to do the expected value formula. You heard me say in class, and I'll say it here again, when you're looking at the expected value formula in the textbook or in the homework problems, they typically ask you to find a variance as well. And there's another formula for a variance, and I'm not going to ask you to use that. So if you're practicing with homework problems, just worry about the mean. Don't worry about the expected, or worry about the expected value, which is another name for the mean. Don't worry about the variance. And then the last topic covered on this exam is the binomial probability distribution. And so you should know the conditions necessary for the binomial. You should know that the 4 conditions that we talked about in class, there's a sample of n experimental units. There's 2 outcomes for each of those experimental units. Is either success or failure. The probability of success is P. The probability of a failure is Q. That's the same on every one of the experimental units, and those experimental units are independent of one another. When those conditions are met, you know you have a binomial, and you can solve those let me say it this way, every binomial probability I give you can be solved either using a function that we learned in class that you used for me on your project, or using a table, and I'll be providing the tables. Try to work these problems using less than or equal to probabilities are the easiest way to solve binomials. The tables give us less than or equal to. One of the functions we looked at in class gives us less than or equal to probabilities. Occasionally, other probabilities can be helpful, but everything can be solved with less than or equal to. And then the last thing with binomials is the mean. The standard deviation are really easy to calculate. The mean is just n times p. The standard deviation is the square root of n times p times q. And so those are the topics that are covered on the first exam. I have a nice little sample exam, cleverly called Exam 1, Sample Exam. And then I have some videos showing you how to generate the answers to the sample exam. Don't watch the videos without trying the exam. Try the exam, see how you do, and then when you get the wrong answers, or if you get the wrong answers, check out my videos. And there's actually a third video down here. I don't know why it doesn't have a preview, but it doesn't. But it has all the answers to the sample exam questions. So hopefully that'll help you prepare. I tried to keep this video rather short. Good luck.